excuses from whining companies. Our product is too complicated to not plan everything meticulously in advance. Our quality expectations are too high to not follow a documented and unvarying plan. Have you ever heard these before?
Never.
Like all the time. As most of the people in this room know, those are fundamental misunderstandings of what agility is. Agility improves quality and thrives on dealing well with complexity. Those are reasons to use agile methods. The next two are more tricky. We have already made large investments in fixed machinery and tooling. Our product design is too tightly coupled to iterate modules without changing the entire design. Those are real problems. We would need to invest in implementing an object-oriented architecture, and we need to invest in flexible tooling. For that, the cost is what would be the price if your competitor started coming out with their new generation of products twice the speed of you. What's the cost of being disrupted? And you measure that against the cost required to re-architect your product and retool your line. And you can make a decision with savvy financials. Then the last two, our vendors are not agile enough to support this approach. We order a part and it takes 6 months, maybe longer. We have a test and it takes about 18 months to run that test. How do we fit this in a 1-week sprint? And key steps of the manufacturing process require too long a lead time to fit into sprints. These last two sound impossible, so I'd like to dive into them. Here's how companies are doing this now in plastics. Protomold is a supplier that works in metallics and plastics. They'll produce something about the size of a car door in 1 day, have it shipped to you within a 5-day sprint for $10,000. If you are currently relying on a plastic part that is smaller than a car door and it's taking you more than 6 months, it's because you're using a legacy supplier. Just change suppliers. This is already figured out. In electronics, I very frequently hear it takes 3 to 4 months for us to get a new circuit board made. I have no affiliation with Rush PCB. They were one of the first 100 results when I searched for circuit boards 24 hours. They will send a circuit board in 5 days for $10 to you. Then I typically hear companies say, but we use 4-layer, highly sophisticated composite circuit boards. We have to rely on specialized suppliers that take longer. Rush PCB supports up to 8-layer. And they go, oh. Even better than that is Arduino, made by Rugaduino. Rugaduino already meets all aviation and military spec hardening requirements. It already passes these challenging tests. They will ship it to you same day worldwide for $40. The advantage of it is, if you make your own circuit board, you then have to train someone how to develop for it. You have to make your own development tools, and you have to make your own test tools. The chip on the right costs $40 a chip. Hundreds of thousands of people already know how to develop for it. It uses processing, which is a derivative of C. It meets all Arduino standards, which means it has many well-maintained software development kits and test suites. It ties into fitness, Cucumber, power tools, and you can even run its simulations in Docker. So the one on the left, you're now at the beginning of your waterfall Gantt chart of how you're going to develop, maintain, and test this thing. The one on the right, you already have the ecosystem. You start using it that sprint. Here's a company that uses this entire ecosystem of parts and scrums the entire delivery for you. Local Motors in Chandler, Arizona in the United States. They take ideas from anyone in the world through the internet. They're a community of people that will buy your product, and they do all types of products, but they're famous for making vehicles, complete vehicles. They take your idea, and people who want to buy those vote for it up and down online. The products that get the most votes, meaning people want to buy it, Local Motors then prototypes it, tests it, and then starts mass manufacturing it in multiple micro-factories. Their micro-factories are about the size of this entire building. So I actually think that's a little large to call a micro-factory, but that's what they do. They then sell it and give you a portion of the profit. All you had to do was send them your idea. They scrummed the entire delivery, including the sale and support. They used the suppliers I've been mentioning so far. Here's Tesla's Model S manufacturing line, part of it. These 5 towers press metal over those stamped steel dies that we saw being machined at the beginning of this presentation. Tesla is on 3 to 5 year model cycles because of this. This is their bottleneck. If you can see it, right under the red thing, there's this big gray thing. That's the piece of steel that's the shape of a car door. That's the stamped steel die. It weighs 40 tons. They can make another of the same car door every 6 seconds. But to change that car door design, they need to make a new stamped steel die, which for them costs tens of millions of dollars. So let's talk about how you can make that fit within a sprint. 3D green sand casting is the best I know right now. Green sand casting has been around for a long time. 3D green sand casting is taking a 3D printer and it prints out epoxy, a type of glue, with the sand embedded in it in 3 dimensions. It can make that mold in the middle in less than a day, and then they compression form aluminum inside, and they have a functional jet engine. They do this every day. By making your stamped steel die out of 3D green sand casting, you can have it arrive within a single sprint to the development team and employed to the mass manufacturing assembly line. Even better than that, make it in the Scrum Room. The Roland DGA is one of many machines that will take a block of aluminum about the size of a shoebox. You put it inside and you press print. It's about as loud as a laser printer, so you can have it in your office. And it cuts out every part of it that's not a car door. The parts are only about this big, so you put 28 of them together to make a car door. So, if you have 28 of these $8,000 machines running in parallel, 4 hours later in the Scrum team, you have a complete stamped steel die to make a new door. That lets you deploy to the assembly line that day. If you wanted to use more traditional machining, a standard CNC vertical mill like this Akuma will be $120,000. It will make the entire door at a time, but when there's a problem, you have to ship the parts out by freight, and it is too noisy and dusty to run in an office. It needs to be inside of a big plastic box to be in an office, or it's in an industrial setting. Even cooler than that, skip metal altogether and make the part directly in high-performance composites. This machine is made by Globe. Their office and factory is right by my house in Seattle, Washington. This machine is about 3 stories tall. It costs $1 million. What it does is it takes rolls of carbon fiber, usually made by Hexcel, in one side. There's little electronic hands inside that compress the composite, apply the resin, apply a bag film, apply vacuum, raise the temperature, lower the temperature, and it outputs a completed part every 8 minutes. It currently makes the hoods of the Chevrolet Corvette. It takes them 1 minute to change that hood design in structural composites. So if Tesla bought these machines, we could have a new and better Model S every minute instead of every 3 to 5 years. Even cooler than that, just print the car out in your office. This is a machine that does this right now. It's called the Cincinnati BAM, Big Area Additive Manufacturing. What makes it different than most types of 3D printing is there's a continuous filament of carbon fiber. As it prints out, there's a continuous strand of carbon fiber making structurally strong parts. So we don't have flimsy plastic, PVC, or PLA 3D printed parts. We have structural carbon fiber parts. Here they are printing out a car for local motors. It took them 2 days to print the car, and they drove it out of the machine. While it was printing, they did walk in with copper windings, and it printed the rest of the motor. It printed the wheels and the bearings, and they drove it out of the machine. Their mass production plan is to have 500 of these side by side. The cost to deploy a new version is 0. So when the Scrum development team produces a new design, it auto-deploys continuous deployment to the mass manufacturing assembly line every sprint. That's what we're talking about when I talk about Scrum in hardware. Here's the largest champagne producer in the United States using Scrum. They're also one of the world's largest wineries, Mission Bell in Madera, California. Their manufacturing facility is 60 acres. I don't know what that is in real measurements. Sorry, the United States is very old-fashioned. This is the head of the winery, essentially the CEO. He's holding a fortune cookie that says, "You will soon make a change at work." This was the fortune cookie he opened the first day they started their Scrum transformation. And he said, "How appropriate." His name's Eric. This is how he started. He took the top influencers in the winery, and this is one of the largest wineries in the world. And he had them each write on a sticky note what they would change about the winery to improve it. And then they each prioritized them. Now he had a list crowdsourced from all his winery of what might make it better. He then made a single prioritized list of goals and missions for the winery. Now we have Scrum. Until we have a single prioritized list, there's still confusion from teams over what to pull next. The first ceremony, Scrum ceremony, was a meta-Scrum, where product owners of newly trained Scrum teams, all going through training, it took them all a week, they did the same process John Deere used. The product owners joined in a meta-Scrum, and they each pulled one card from this executive backlog. Eric tracks on a burn down, an executive level burn down, when each of these epics is trending to complete. That epic, that burn down comes up from each component Scrum team. So each of those product owners has another Scrum team that executes on stories split from each one of these epics. But this is a single prioritized list, so there's never a question of priority across the entire company. Here's one of the teams. This is the Champagne team. This is one Scrum team, and they do everything from venting to cellar operations to pumping to distilling to packaging to sales promotion and delivery to setting up supplier relationships and trucking, and even researching the elasticity increase of the human heart under viticulture influence, so they get grants for health enhancement. This is all done by the same team for Champagne end to end. What you see on the wall behind them in sticky notes is their value stream map of every step from idea of a new Champagne product to that product in stores and revenue being recognized. And they're scrumming it to shorten the value stream map right there. This is their Scrum Room. Not bad. This is also their Scrum Room. And this is also their Scrum Room. The point I'd like to make is Scrum and Hardware, the best I can tell, is actually exactly the same as Scrum anywhere else. The same 3 roles, a product owner, a Scrum Master, and the development team. The same 5 events or ceremonies or meetings, call them whatever you want. The same 3 outputs. The only difference is the cards in the backlog and what their Scrum Room looks like. Another difference is, in software, the teams usually already understand object-oriented architecture. In winemaking, we did have to explain what that meant. That said, they understood it in about 30 minutes. Here's their information radiator. It said, number of wine bottles that have fermentation continuing after the desired level. So sugars continue to deplete, and it harms the tastes. It has bottle spoilage and mislabeling. Those are all still good metrics, but they've replaced them with velocity, quality, which is a summation of this, and team happiness. This is now posted for each Scrum Room across the winery. Here's a company that makes fuel injectors for jet engines for military and commercial aviation, and this is their executive action team backlog. So that's the head of this manufacturing facility, and he has all these epics that he cares about. Deploying standardized work across the factory, communicating with other factories in a superior way, refactoring the mass manufacturing assembly floor. Those are all epics on sticky notes. And right now he's being forced to prioritize, which he never has before. Before, he would tell people to do Scrum, but they'd wonder why they had competing priorities and they were still asked to produce all the legacy metrics. Now that they're finally relaunching the top of their manufacturing facility using Scrum, it starts to flow more naturally. Here's KVH Systems. They make streaming internet data and video for maritime. They're the largest provider of ocean-going data worldwide, and this is their Agile team launch. They're splitting their entire company into teams. This is a picture of one part of it. There are thousands of employees, and they're becoming cross-functional, where instead of having a mechanical engineering team, an embedded engineering team, a thermal engineering team, a materials manufacturing process team, they have one of each on one team, and they're each scheduled to complete a mission from the corporate backlog, which is an epic. I'd like to show end-to-end one company doing this. Where might you expect the most disruptive innovation to come from? If you said illegal street racing, you'd be right. They have no respect for the traditional institution and are fine with trying something new. This is the owner of 2 companies, Rocket Bunny and Liberty Walk. This guy wants to be a supplier to Lamborghini and Ferrari, but he's just some guy with no supply chain. This is how he became a supplier to those 2 companies. First, he 3D scans the back of a Ferrari 458 Italia and a Lamborghini Aventador. So he buys a $20,000 3D scanner. By the way, they're $400 now. And he scans the car. Then he draws the parts he wants to make. In this case, it's a bumper, side skirts, and rear tail. He now makes interior parts and mechanical components, but in this example, it's the exterior. He puts it on Facebook that day and says, "Who wants that?" By the number of likes he gets, he decides which one to make. The next day, he machines it out of foam, wraps it in carbon fiber, and puts it on a car. The next day. He then polishes it, takes it for illegal street racing, which generates a ton of publicity, and then takes it to a show. The same week, he then sells it. I'm not sure if you can see, but there are 5 Lamborghini Aventadors in a row here, and they were all just sold. He is now a direct supplier to Lamborghini and Ferrari without ever asking them beforehand. If your suppliers aren't able to integrate with your product and deploy working product in less than 5 days, find different suppliers. John Deere is doing this now with the cabs of their tractors. Here's the takeaways that I think I'm learning and I would like to share. As market responsiveness becomes more important than scale, adding agility to manufacturing might be essential. Scrum enhances lean with agile practices to the physical R&D and manufacturing world. If you're talking to a manufacturing team, this is what I think you might want to recommend, and please let me know as you learn more. Scrum teams are our lean cells. Contract-first design enables us to make changes in parallel within a sprint length. Without this, we're still on 3 to 5 year iterations because it's the cost to re-engineer the entire project. Shorten supply chains and keep the line flexible. All of the reasons companies think they can't do this have already been solved. Companies are starting to leverage agile manufacturing to succeed in the market. Is your client's competitor one of them? Folks, thank you very much. I appreciate getting a chance to talk with you. I'm sorry I'm so torn in the voice. But if there's even a minute, I'd love to take a question. And if we run out of time, you can email me or tweet to me. I'm justice@scruminc.com with any question anytime about Scrum or Scrum and Hardware. What I want to do is have more Scrum coaches feel comfortable working with manufacturing clients so we can save the environment. Because by improving mass production every 3 to 5 years, we might not get there in time. By improving mass production every 5 days, we've got a chance. To me, this is actually a moral imperative, so I'm very interested in helping coaches feel comfortable working in the hardware domain. Email me anytime. Do we have any time for questions? Or
no time at all. you expired your time box, you know.
Thank you guys very much.